Okay, we have here today on the board a limit problem. We've got the limit as x approaches pi over 2 of tan x minus secant x. Okay, to get started with this, what we can kind of do is take pi over 2 and just plug it in to get a sense of what we're looking at. Maybe we can do this real easy. So if we evaluate tan at pi over 2, tan at pi over 2 is actually going to infinity. And that's because tan is sine over cosine. Cosine at pi over 2 is 0, so we're like dividing by 0 there. And then secant x, well, that's also going to infinity because, again, it's 1 over cosine x. Because cosine at pi over 2 is 0, again, we're like dividing by 0. So then what we're looking at is infinity minus infinity, and that's what's called an indeterminate form. And that means we don't really know quite what's happening yet. This could mean 0. This could be infinity. This could be 5. We don't really know, so we need to do some more work on this thing. What I want to do is rewrite this in terms of sines and cosines and see if we can manipulate with trig identities a little bit or algebra. Tangent is sine x over cosine x. Secant x we can write as 1 over cosine x. So then next we have a common denominator, so I can actually put these together and write this as sine x minus 1 over cosine x. Again, this is a problem that cosine at pi over 2 is 0 and we're dividing by 0, so we need to do something about that. What I'm going to do, let's multiply top and bottom by cosine x. Then doing that, this is going to become cosine squared x, but what I can do is rewrite cosine squared x using the identity that this is the same thing as 1 minus sine squared x. So now I'm just going to rewrite this. In the numerator, we're going to have this sine x minus 1 over cosine x. Now for 1 minus sine squared x, I'm going to break that up as a difference of two squares. So I'm going to write it as 1 plus sine x times 1 minus sine x. Well, what I can do here in the numerator, I can reverse the sign on this one, multiplying by minus 1. I don't want to change it, so I'll multiply a minus 1 on the cosine x, so we're still of the same expression here in the numerator. And now we can cancel this 1 minus sine x with this 1 minus sine x. Now at this point, let's just try to evaluate it again at pi over 2. So when we look at cosine at pi over 2, this is going to be 0 in the numerator. Of course, the minus sign doesn't matter in this case. And then here we're going to have 1 plus pi over 2 at sine is 1, so we're going to have 1 plus 1. So we end up with 0 over 2, but that's just going to be 0. So it's pretty nice that even though we had infinity minus infinity, the indeterminate form, we're able to manipulate it and get a number answer here, like 0. Now at this point, you could be thinking that, hey, infinity minus infinity, that's the same thing, so of course it's 0, right? Because if you just subtract infinity from infinity, you get 0. Well, that's not always true. That can be true, but it's not always true. You can't treat infinity like it's a variable. This isn't the same thing. Like, yes, if you had x minus x, that's 0. Just because that works doesn't mean you can use the same thing on infinity. Let's look at a real quick example though to show this. So let's say we're looking for the limit as x approaches infinity, and we want the limit of, say, x squared minus x. Well, you plug infinity in here, infinity squared is going to be infinity. Then you plug infinity here, infinity at x, this is going to be also infinity. So we have infinity minus infinity again, same exact indeterminate form we had up there. And you may want to say that that's 0. But actually, we can take this here, this expression x squared minus x, and I can factor an x out of this. And then if we just look at this limit as x is going to infinity, now we look at this and we have actually infinity times infinity minus 1 is still infinity. Infinity times infinity, this is actually infinity. So in this case, infinity minus infinity is definitely not 0. In this case, infinity minus infinity is going to give me just an infinity. So that's it. We'll stop it there. Thanks so much for watching. Have a great day.